Hey everyone, welcome to the Pre-algebra 11.5 video where we're going to be talking about interpreting data today. So before we get into the stuff we have for today, we need to review percent and just make sure we're okay with that. And so if I said, what is 5% of 240? What's the operation you would think of? Well, I hope you think of multiplication, and we're going to multiply 5% times 240. However, we can't leave 5% as 5%. We need to change it to a decimal, and the decimal of 5% is 0.05. And if you forget how to get there, remember the decimal in 5% is technically invisible, and he's right there. And to take it from a percent to just a true number or a decimal, we're going to move the decimal 2 spaces to the left. Okay, and that's how we get 0.05. And then you take 0.05 times 240. And when you do that, you should get an answer of 12. All right. So one reason we interpret data is so that we can make predictions, okay? So we're going to go through this problem. 5,000 families were surveyed about their TV watching habits. 780 responded that they watch Duck Dynasty. And so we're going to assume this is 5,000 just random American families, okay? 780 responded that they watch Duck Dynasty. So there's approximately 105, this should be million. There are definitely more than 105 households in the United States. 105 million households in the U.S. About how many of them watch Duck Dynasty? So what we got to figure out is, man, how am I going to go from this little sample to all this? Well, the reason we do sampling is so that we can make some predictions. Now, again, our prediction is not going to be probably perfect, but it is going to be helpful. So let's figure out of these 5,000 families that were surveyed, let's figure out how many responded that they watched Duck Dynasty. So how would we do that? Think about this. If 5,000 out of the 5,000 said, yeah, we watched Duck Dynasty, well, that would be all of them, or 100%. And you would get that by doing 5,000 divided by 5,000, right? It'd be the people who said, yes, we watched Duck Dynasty, divided by the total number of people surveyed. Okay, and 5,000 divided by 5,000 would be 1, and 1 as a decimal would be 100%, because when you take a number such as 1 and make it into a percent, you take the invisible decimal, sometimes it's visible, it depends on the number, move it 2 places to the right and add the percent, and so it'd be 100%. So here, though, we got to figure out, okay, well, there's only 780 who said that they said, yes, we watched Duck Dynasty, and there were still 5,000 that were surveyed. So we need to take 780 and divide it by 5,000. And when you do that, what you'll get is the decimal, sorry, psi, oh, try to move psi, can't move just psi. Well, unfortunately, we have to keep rolling with that. 780 divided by 5,000 equals 0.156, okay? Now, we want to take that 0.156 and let's interpret that as a percent. So we need to move our decimal 2 places to the right, and now it is 15.6%. So what does that mean? Well, it means 15.6% of these 5,000 people watch Duck Dynasty. So now what we're going to do is we're going to take that 15% and apply it to the population that our sample represented. So there's 105 million households in the U.S. About how many of them watch Duck Dynasty? Well, let's see. If 100% of our sample watch Duck Dynasty, then we could say, well, all 105 million households in the United States watch Duck Dynasty. But of course, that's not true. So our sample indicated there was 15.6% of people that watch Duck Dynasty in that sample. So now let's take that sample and apply the percent from the sample and apply it to the population of 105 million households. Okay. So what we can safely assume is that 15.6% of the sample watch Duck Dynasty, then probably 15.6% of the whole entire population will watch Duck Dynasty. Roughly, okay? So how are we going to do this calculation? Well, again, we need to make our percent into a decimal. So it's going to be 0.156 times 105 million. And when you do that, you end up getting 1,638,000. So that is, let's see, 16,380,000 families probably around there watched Duck Dynasty out of the entire United States. So 15.6% of 5,000 was 780. 15.6% of 105 million is 16,380,000 families. So I want you to try this problem. The city of Austin contains approximately 2,000 families that have 8 or more children. 400 of these families were sent a survey asking them, how many pounds of flour do you go through in a week? Because obviously they're going to use, a fair bit. Okay, baking a lot, got a lot of mouths to feed. Well, only 150 of those families responded. And out of those 150 families, 65 of them go through more than 4 pounds. So what we're going to do is find out that out of all the Austin families with 8 or more children, how many go through we should say more than 4 pounds of flour? There, that's fixed up. So go ahead, pause the video. I want you to try this on your own, see how you do. I bet you can get it right, and then we'll keep moving. All right, so let's check this out. What we need to find is how many people actually responded. Okay, how many people responded? Because it's really the only data we have is if people responded. If they didn't respond, we can't really make assumptions about them. So let's see, only 150 of the families responded, okay? But out of those 150, 65 of them go through more than 4 pounds. So how do we figure out what percent of the sample, which is those people who actually responded, how many of those people go through more than 4 pounds? Well, out of those 150, 65 of them go through more than 4 pounds. So I'm going to take 65 and divide it by 150. And when you take 65 and divide it by 150, what you end up getting is 0.43 repeating, okay, as a decimal. So I want to know, actually, what is this as a percent? Well, let's move our decimal 2 places to the right, and I guess we'll round to the nearest whole percent. So it would technically be 43.3 repeating percent. We'll make it 43%. Okay, so 43% of our sample go through more than 4 pounds. But I want to know, of all the Austin families, how many actually go through more than 4 pounds of flour? All Austin families that have 8 or more children. Well, let's see. There are 2,000 families, right, that fit this category, the people we sampled, right? People who have 8 or more children. Now we know that 43% of the sample go through 4 or more pounds. So what we can do is interpret that 43% of the 2,000 families that have 8 or more children will probably go through about the same amount. So we're going to take this 43% and multiply it by our population of 2,000. Now, we have to make this 0.43, multiply that by 2,000, and when you take 0.43 times 2,000, you should get 860, okay? And our label is going to be families. Now, what does that mean? Well, it means that out of the 2,000 families that live in Austin that have 8 or more children, approximately 860 of them will go through more than 4 pounds of flour in a week. All right, so next let's talk about margin of error. What's margin of error? Well, margin of error is something that allows us to not be so hard and fast on the facts, okay? Now, what do I mean by that? Well, I think the best way is just to use some sort of problem to explain it. Let's say there was a survey done, and the survey asked a handful of people in Cedar Park, how many do you have dogs? Yes or no? Okay, and we'll say that 55% of the people of Cedar Park residents said, yeah, they own a dog, but then they have this little plus or minus 3%. Plus or minus 3%, that is our margin of error. And what that means is that, you know what, the sample we took to figure out approximately how many people in Cedar Park have dogs is not going to be perfect, okay? There's no such thing as perfect. So we built in these margins of errors so that if someone goes, oh, well, I did my own survey and only 54% of Cedar Park residents have a dog, you're a liar, City of Cedar Park. So that sort of thing doesn't happen, all right? So the margin of error is plus or minus 3%. So what it means is we take the percent advertised, and we're going to both add 3% to it, and then we're also going to subtract 3%. And that's going to actually give us a little more realistic set of numbers, right? So 55% plus 3% would be 58%. 55% minus 3% would be 52%. So what that really means is that, okay, maybe 55% of Cedar Park residents own a dog, but more realistically, because our sample that we took, and that people answered our survey, it's not going to be perfect. It's more realistic to assume that, and I should really flip these around, 52%. It's more realistic to assume that 52% to 58% of people in Cedar Park actually own a dog. Might not be exactly 55%. Okay, so a survey of a random sample of voters predicts that in the upcoming mayoral election, Jim Snyder will receive 48% of the votes, and Molly Watson will receive 52% of the votes. Now, this data comes with a margin of error of plus or minus 3%. Can we predict who will win the election? So I want you to pause the video, and I want you to try this on your own. I bet you can figure it out. Play it when you're done, and we'll run through it. So let's split this up into both candidates. Okay, so we're going to talk about Jim, Snyder, and then Molly, right? Now the survey predicts that Jim will receive 48% of the votes. But again, that comes with the caveat that there's a margin of error of plus or minus 3%. So what is 48 plus or minus 3%? Well, that'd be 45%. What's 48% plus 3%? Well, it'd be 51%. So really, because of the margin of error, Jim's probably going to receive not 48, but between 45 and 51. Maybe he'll get exactly 48, but it could be anywhere from 45 to 51. Now, Molly, she's supposed to get 52%, but her data comes with the same margin of error of plus or minus 3%. So let's take away 3% from 52. We get 49%. And then let's add 3% to 52, so that'd be 55%. So Molly may get 52%, but really she's more likely to land anywhere between 49 and 55. So can we actually predict who will win the election? Well, if you count their margin of errors, Jim gets the lowest, right? He could get at a minimum of 45% of the votes, which would mean Molly would get the rest, which would be 55%. However, it's possible that Jim could get 51% of the votes. And if he did, that means Molly gets the rest, which would be 49. So it's possible that either of them could win. It's possible they could both get 50% and tie because 50% falls within both these ranges. So actually, we cannot predict who will win based on the data we've been given. All right, guys, that's actually all I have for you on this video. I look forward to seeing you in class talking more about this. Hope you have a good night, and I'll see you soon.